Good afternoon, guys. We are looking now at the Unit 6 test review. Your test will be this Thursday, so we're taking 2 days for the review. We want to make sure that you really understand all of these concepts. This review is going to be a little bit different. You'll notice that there are 2 of each numbered question. So you're going to use this video to complete the unshaded questions, and we're talking about the numbers here. So the unshaded questions I'm going to do with you on the video, and then the shaded questions that follow right underneath you're going to do on your own. And so we'll do number 1 together, then you'll pause the video and do the shaded number 1 on your own, and then you'll bring your paper to me or to Ms. Holliday for your stamp. And that's how you're going to get your grade. So make sure that you bring it to me or Ms. Holliday after each shaded question that you do so that you can get your stamp on that one. We know you're going to get this one right, but this is the one that we want to make sure that you can do on your own. So make sure that on the unshaded questions that we're doing together that your paper looks just like mine, that you work out all the steps, and then the shaded question should be done the one that you're doing on your own should be done pretty much the same way. So it'll be very similar, and then your test will be very similar to these questions as well. So you should be very prepared for your test by the time we get to Thursday. Okay, number 1 says, the graph below displays the growth of a lizard in millimeters. What is the unit rate of the lizard's growth in millimeters per month? So I'm looking at this. I see first that my x-axis is months, and it goes by ones, 1, 2, 3, all the way up to 10. And then I see that my y-axis is the length of the lizard in millimeters, and it goes by 100s, but it skips a line in between. So I know that this first line is 50 millimeters, so I'm going to go ahead and write this in. That's 50, then 100, then this is 150, 200, 250, 300, 350, 400, 450, and 500. So I like to go ahead and write those in just so that I don't get confused and think that the scale is a little bit different. So it's asking for the unit rate of the lizard's growth in millimeters per month. So when it says per month, the biggest thing that I want to look at is 1 month. So I want to know how many millimeters does he grow in 1 month. And so I'm going up from 1, all the way up from 1 to right here. And then if I come over here, I'm going to see that that is halfway between 50 and 100. And so that's 75. 75 millimeters per month. And if we test that out, that means that 2 months would be 150 millimeters. So that's an extra 75. And then if I go up by 75 more at 3 months, that puts me at 225. See how I'm kind of able to take this over each time. 225 plus 75, that puts me at 300 millimeters in 4 months. So I can prove to myself what exactly I'm doing here. But the big thing we want to keep in mind in these types of problems is it says millimeters per month, so I want 1 month. Per month means for 1 month. So this would be my answer right here. 75 millimeters per month. So the next question is what you're going to do on your own, and there are no answer choices for this one. So I need for you to write your answer in the box. Make sure that you prove your answer on the graph, kind of like I proved my answer here. I showed my thinking, and I'd like to see your thinking as well. So please complete the shaded problem 1 on your own, then bring your paper to me for a stamp before you unpause the video and continue to number 2. So please pause the video now. Okay, number 2 says the following table displays the approximate number of days, y, in X weeks. So X is our weeks, Y is our days. which equation can be used to determine the number of days, y, in X number of weeks? So I'm looking for the formula, which equation we could use to display this data. So I know it says approximate. Obviously, it's 7 days in a week, not approximately 7. But I want to figure out, first of all, which of my equations are in the right format. So they all need to be in y equals mx plus b. So that one's good. That one's good. It just doesn't have a plus b. This one I need to get rid of because we need y equals, not x equals. And then this one looks good. Okay, so I want to see which one of these fits my table. So here, I'm going to actually do these in different colors here. Okay, so A, we'll do that in orange. It says y equals x plus 6. Okay, so that means 7 equals 1 plus 6. Is that true? Yep. Okay, but I'm not going to just circle A because I need to test the rest of the table. So let's move on to the second pair. 14 equals 2 plus 6. Well, the first one worked, but this one does not work. So that means that A is out. And you could actually keep checking these if you wanted to. Okay, let's check B. Y equals 7 times x. So I'm going to say 7 equals 7 times 1. Okay, that one works. That is a true statement. Move on to the next one. 14 equals 7 times 2. Well, that one works too. 21 equals 7 times 3. That is true. Test the last one. 28 equals 7 times 4. And that is also true. So I think that B is going to be my answer. But just to be sure, let's go ahead and look at D. We'll do this one in blue. And I'm going to say, okay, y equals x divided by 7. So that would mean 7, this y, equals x, 1, divided by 7. Well, 7 does not equal 1/7. That is not even going to work. So I can go ahead and get rid of D. And I know that B, y equals 7x, is my answer. So the shaded number 2 is the one that you're going to do on your own. And just like last time, there are no answer choices, so you need to write your full equation here. It needs to be in y equals format. So we're talking about y equals something x. Okay. So please complete shaded number 2 on your own. Then bring your paper to me for your stamp before you move on to number 3. Please pause the video now. Number 3 says to complete the table that can be generated from the equation y equals 3x plus 2. Now on your test, you'll have a question kind of like this, except it's going to give you an equation, and you'll have several tables to choose from, and you have to see which table fits. So if I were you, I would just make my own table, and then find the one that matches. Or you can actually test out each table answer choice, but that may take a little bit longer. Whatever works for you is great though. But the way that we're going to figure out what our y's should be is by plugging in our x's and then figuring out what y equals. So let's do x equals 1. I'm going to start with my equation, y equals 3x plus 2, but I need to plug in 1 for x. So y equals 3 times 1 plus 2. And so y equals, that's 3 plus 2. So y equals 5. So that means 5 is going to come over here. That's my y value. So when I plug in x, I end up getting y equals 5. do the next one. We're going to use 2 now. So y equals 3 times 2 plus 2. Then y equals 6 plus 2. Then y equals 8. So here, when x equals 2, and I plug that in, I get y equals 8. Now let's plug in 3 for x. So I'll come over here. Y equals 3 times 3, that's my x value, plus 2. So that's y equals 9 plus 2, and y equals 11. So notice I'm going up by 3 each time, and that's my slope, that's my constant, so that's what I would expect it to be. We have one more to test. I'm going to plug in 4 now. Y equals 3 times 4 plus 2. Y equals 12 plus 2. Y equals 14. Now make sure if you're given a table that has different values, maybe it skips around and goes -3, 0, 1, 2, 7 or something like that for your x's, make sure that you're plugging in the right values and looking at what the y equals for that number. So the next one for you to do on your own uses the equation y equals 3x plus 1. So I need to see the work for all 4 x values. Now you're going to complete shaded number 3 on your own. Then bring your paper to me for a stamp before you go on to number 4. So please pause the video now. Number 4, let's look at the scatter plot. It says Frank's progress on his math tests is displayed in the following graph. And we have the hours and his test grade. And so this would be the hours that he studies and then his test grade. So each one of these dots represents a test that he took. So he's taken a lot of tests, and you'll see it doesn't make an exactly straight line, but it is a linear relationship. So based on the graph, if Frank maintains the same progress and wants to score a 90, how long does he need to study? Okay, so that's our question. How long does he need to study to score a 90? So what I'm going to do is find 90%. His test grade to be a 90 would be halfway between 80 and 100. So this is a 90. And so I'm going to just kind of emphasize this line right here. This is a 90. Now at 3 hours, that would be right here. And that doesn't really seem to be where the dots are headed. 3.5 hours would be right here. Okay, that puts me right on the line. I'm blocking that a little bit. That puts me right on this line. So if I put a dot right there, that would go along with my linear relationship. So that might be it, maybe. 4 hours would be right here. That's a little beyond. And then 4.5 hours would be way over here. I would expect his grade to be over 100 with 4.5 hours of studying. So the whole point is that we want to find where can I put a dot along this line where it kind of stays within the group of all the dots and doesn't go way outside somewhere. So with 3.5 hours of studying, that puts him right there, right where a 90 should be. On the next question, make sure that you read the question very carefully. It's talking about 2 kilometers. And then you're going to write your answer right here. So make sure that you have units. And I know I put this as miles. This should have been kilometers. I'm sorry about that. typo. So if you'll change that to kilometers and then write your answer here with the kilometers units. Now complete problem 4, the shaded one, on your own. Then bring your paper to me for your stamp before you move on to number 5. Please pause the video now. Number 5 says line M has a slope of 1.5. So I'm going to underline slope of 1.5 and goes through the point 210. So it goes through that point. Which equation best represents line M? Okay, so the first thing I want to do is get my slope figured out. My slope is 1.5, and remember that's the number that comes before x in the equation. So let's see if we can get rid of anything here. Y equals 1.5x, y equals 1.5x. Okay, they all start with y equals 1.5x, so I can't get rid of anything there. So now what I need to do, the quickest and easiest way to actually figure out your equation will be to plug this point into each equation and see which one ends up being equal. So we need to remember that 2 is our x value and 10 is our y value. That's really important that we know which is which. So I'm going to start with this equation. So let's start by writing y equals 1.5x plus 10. And I'm going to plug in 10 for y. So let's do 10 equals 1.5 times 2 plus 10. And then 10 equals, let's see, 1.5 times 2 is 3. And 3 plus 10 is not 10. So the reason on the table before, when we were trying to complete the table, we were just plugging in x values and then we were trying to figure out the y. This is different because they're giving us an x and a y, and so we're testing to see which one of these equations fits this point, fits the x and the y together. So A is gone. Let's look at B. Y equals 1.5x minus 10. So I'm going to plug in 10 for y, plug in 2 for x, and then start trying to solve. So 10 equals, we already know 1.5 times 2 is 3. Okay, 3 minus 10 is not 10. 3 minus 10 would be like negative 7. So we can get rid of that one. Now let's come over to C. We will do y equals 1.5x minus 7. Let's plug in 10 for y. We're still plugging in all the same numbers because this is the point that we need to fit. So it's all about that one point. 1.5 times 2 minus 7. We know that 1.5 times 2 is 3. 3 minus 7 is negative 4, not 10. So that one can go away. Now I am not going to be lazy and just circle D, because if I made a mistake somewhere, I want to be able to catch it. So let's test choice D. 1.5x plus 7. 10 equals 1.5 times 2 plus 7. We are really good at multiplying 1.5 times 2. That's 3 plus 7, and 3 plus 7 does equal 10. So that is my answer. So the whole thing that I needed to do was double check my slope. That needs to come first. And then I'm plugging this point into each equation to see which one actually works out. None of these worked out. They were all false. So you're going to do the same thing down here. Slope of 3.5, and here's your point that you're going to plug in. Make sure that you look back at the one we did together to see what steps we did. And I need to see all of this work for you to get your stamp on this one. Now I'd like you to complete shaded problem number 5 on your own, and then bring me your paper so that you can get a stamp before you move on to number 6. So please pause the video now. Number 6. The scatter plot below represents the ages and weights of a group of employees. Based on the trend line, okay, so this is our trend line, what would be the weight of a person who is 42 years old? Okay, so 42 years old, and we're looking for the weight. So I'm going to look here and I see, okay, this is 24, this is 28, so then this would be 26, 30, 32, 34, 36, 38. So 42 would be one more line over. That would be 42. I know that's kind of hard to see. Let's see that. So this would be 42. So I'm going to do as close as I can, draw a straight line here, just like we did over on number 1. But now I'm looking for something to be 42 on the x-axis. Now, 221 pounds, well, let's see. If this is 75, then this must be 50 and 25. So I'm going by 25s here. 100, 125. It's always a good idea to write in the numbers that are skipped. So this is 175, 200, and 225. So we got to figure out our scale first of all. So 221 would be way closer to 225 than 200. That's going to be about right here. Okay, so this is not a point on the graph. 162, okay, so what I'm pointing out here is 225 would be way down here. It wouldn't be up here on this line that continues on and on and on, my trend line. 162 pounds, that's about halfway between 150 and 175. Well, that would be for a person who's about 34 years old. See? That hits about 34. So that one's not right. Let's get rid of that one for sure. 238 pounds. Well, this would be 250 right here. So let's go about halfway between 225 and 250. Right here. Okay, yes, that hits 42 years old and hits my line, so they all hit together. So this is a maybe. 67 pounds, that's halfway between 50 and 75, and that is for like a 24-year-old. Which most 24-year-olds do not weigh 67 pounds, but you get the idea. So, not that one. Alright, so it's between 221 and 238. Well, 221 was right here, and that was a little bit below my trend line. So 238 is going to be my best bet. It hit right here, right at 42, and right on my trend line. Now, please complete shaded problem 6 on your own, and then bring your paper to me for your stamp before you move on to number 7. So now you can pause the video. Thank you. Number 7. A table of data is shown below. Based on the table, which equation in the form y equals mx plus b models the linear relationship? So here's our table. Notice that our x values kind of skip around. They don't go consecutively. We jump from -3 to -1, then to 0, and we jump to 2 and 3, and then we skip over to 5. So we're going to have to actually test these x and y pairs. So if you look back at number 5, on number 5, we had 1 point, we had an x and a y, and we had to plug each of those into the equation, or we had to plug the y and the x into the equations to see which equation was true. We're going to do the same thing here. The only difference is we have several points that we need to test. So we're going to need to kind of write small and be organized to make sure that we have room and make sure that we are able to kind of follow our own work. So let me start out working this with you. First of all, it says in the form y equals mx plus b. Well, if any of these are not in that form, I can get rid of them, but all of these are. So, oh well, we can't get rid of any choices based on that. But we can start plugging in. So I'm going to take y equals negative 4x plus 3, and I'm going to start plugging in my x and my y's. So y equals negative 4x plus 3. So I'm going to take, you know what, I'm going to take the easier ones. I'm going to do 0 and 5. I'm just going to start with this one. And if this one works, then I'll go and start trying the ones that are a little bit tougher. Because I know it's got to fit for all of them, so I might as well test the easy ones first. So y is 5 equals negative 4 times 0 plus 3. Well, okay, 5 equals, anything times 0 is 0. 5 equals 0 plus 3. Absolutely not. That does not work. And if it doesn't work for that one, then it can't be right. Now, if I get to the end and I've tested all 4 choices and I still don't have a right answer, then I should go back and kind of start looking and see if I made a mistake. But for right now, it doesn't look like that one's going to be our answer. Okay, now let's try B. Y equals 3x plus 5. So I'm still going to start with this one since it's the easiest to plug in. So let's do 5 equals 3 times 0 plus 5. 5 equals 0 plus 5. Well, that one works. So maybe that's right. Let's test another one. Now let's test 2 and 11. So 11 equals 3 times 2 plus 5. That would be 6 plus 5, and that is 11. Looks like this one might work. Now let's try 14 and 3. 14 equals 3 times 3 plus 5. So all we're doing is plugging in and testing. 9 plus 5, yep, that's 14. So far, all of these work, those 3. Now let's test 20 and 5. I'm going to come over here. 20 equals 3 times 5 plus 5. So 3 times 5, that's because x is 5, and then plus 5. 20 equals 15 plus 5, and that is true. Looks like this is probably going to be our answer. Let's find some space here and go back to these numbers. So let's do negative 4 equals 3 times negative 3 plus 5. So negative 4, 3 times negative 3. If the signs are different, the answer is negative, so that's negative 9 plus 5. Well, if I have negative $9 and then I get $5, now I have negative $4, so I'm closer to 0, so that one works. Let's test the next one. 2 equals 3 times negative 1 plus 5. So 3 times negative 1 is negative 3 plus 5, so that's negative 3. then -2, -1, 0, 1, 2. So that works. So I've tested all of my pairs, and this one seems to be the answer. But let's go ahead and just double check how we would plug into these equations, just so that we have the practice. So I'm going to say y equals 5x plus 3. I'm going to go back to my easiest pair. So 5 equals 5 times 0 plus 3. So that'd be 5 equals 0 plus 3. That does not work. I didn't think it would, but it's good to double check. And the last one. Where's some space? Let's see. Y equals 1/3 x plus 5. So 5 equals 1/3 of 0 plus 5. Well, 1/3 of 0 is 0, so 5 equals 0 plus 5. That one works. Uh-oh. Let's test another one. Better double check. So let's do 11 and 2. 11 equals 1/3 of 2 plus 5. Well, 1/3 times 2 is 2/3, or 0.66 plus 5, and that is not going to give me 11. That'll give me 5 and 66/100. So notice how it worked for this pair, but then when I started testing others, it didn't work. So B worked for all of my pairs. I need to make sure that I plug in y first, and then x is to the right of the equation, or right at the equal sign. So we want it to match correctly. Now please complete shaded number 7 on your own, and then bring me your paper so that I can give you your stamp before you move on to number 8. Please pause the video now. Number 8, this one is going to go back to slope, which we were working on a couple of weeks ago. The table shows the amount of money Larisha had as principal in her savings account each month. If you were to graph this proportional relationship, what would be the slope? Now, first of all, they're talking about savings accounts and principal and all that stuff. Don't get confused. This has nothing to do with calculating interest because it's not asking us anything about interest. So we're going to ignore all of that. All we want to know, we don't care about any of this, because none of that is relevant. None of that matters. All we care about is, if you were to graph this proportional relationship right here, what would be the slope? Well, we know that slope equals the change in y over the change in x. Okay, and this little triangle is the Greek letter delta, and it means change. Okay. So it's how much does y change over how much does x change. Well, here, y goes up by 20, and here, x goes up by 1. So I'm going to say the slope equals 20 over 1. And I know that that's the same as 20. 20 divided by 1 is 20. Now let's test another pair. So if I went from 120 to 140, that goes up by 20. This goes up by 1. So it's still 20 over 1, which is 20. That goes up by 20. This goes up by 1. 20 over 1 equals 20. So we need to put this in our griddable here. Obviously it's positive because it's going up 20 and up 1. And then here's my decimal point, so I need to put my 20 right here. And it's very important that we bubble, and that we bubble neatly and completely. That way the machine can read our answer. And it needs to go right here before the decimal point. If you want to put in these extra zeros, you can do that. That's fine, but it's not necessary. Now I'd like you to complete problem 8, shaded number 8, on your own, and then bring your paper to me for your stamp before you move on to number 9, please. So I'd like you to pause the video now and complete number 8. Number 9. Jared performed an experiment in his science class. He dropped pebbles into a jar of water and recorded the height of the water after the pebbles were added to the water. Okay, so that sounds a little confusing at first. Let's think about it. Okay, so he has a jar of water. He's dropping pebbles in. So as I drop pebbles into the water, eventually that water is going to start rising. Okay, it's going to be higher water level the more pebbles I add. The graph below displays the results of his experiment. Write an equation in the form y equals mx plus b to represent the height of the water, which is y. Okay, so the height of the water in inches is y, after adding the marbles. So the number of pebbles here is x. And I know I wrote marbles here. It should say pebbles. This is our x. So the number of pebbles that we're adding, and then how high the water is. And notice that it's not going up very fast. These must be pretty little pebbles. Now first I need to make sure that all of my equations are in the right form. Y equals mx plus b. And it looks like they all are, so I can't get rid of anything there. So now I'm going to start. Remember, the only thing we need to write an equation from a graph is the slope and the y-intercept. So we need our slope and we need our y-intercept. Now I'm going to start with my y-intercept because that's easy. Where does it hit the y-axis? Well, it hits right there. Okay, what number is that? I see that this is 5, so it must be 0, 1, 2, 3, 4, 5. So that works. So this is 2, which means that my y-intercept equals 2. Remember, this right here is your y-intercept, the plus b. So I need it to say plus 2 on the end of my equation. All right, so I can already get rid of this and this and this. This is the only one that says plus 2. But I'm not going to move on yet. I want to double check that my answer is right and I haven't made some mistake somewhere. So I'm going to find my slope. In the last question, in number 8, we found our slope by taking the change in y over the change in x. Well, another way of writing that is rise over run. Okay, because our rise is our y value, that's how much we're going up or down, and the run is x, how much we're going left or right. So I'm going to count from this point right here. I already know what point that is. It's 0, 2. And I'm going to find another easy to use point. So somewhere where it's not in the middle, but where it hits an actual intersection. So this is 15, 6. So my rise here, I've gone up 1. So my rise is 1. And then my run is all the way over here to 15. So from 0 to 15, that's my run. Rise over run. I go up 1, I go to the right 15, and then I hit another point. And I could keep doing this and I would keep hitting points. Now remember that our slope is this m. And I seem to have made a typo. I am very sorry. This equation right here, I guess none of these answers are right because I forgot to fix my answer choice. So the correct answer, let's just write the right answer here. Y equals, it needs to be 1/15. 1 over 15 x, that's my slope. And my y-intercept has to be positive 2, so plus 2. And this is the answer. Now I have checked the next question that you're going to do on your own, and I promise the right answer is there. So you're not going to have to figure out and rewrite the equation. One of those is the right answer. So here is your question to work on your own. And remember, the only thing you need to come up with an equation from a graph is your y-intercept, that's your plus b, and your slope, your rise over run, which is your m. Remember, k, that's our constant. It's constantly going up and over by the same amount. So now please complete shaded number 9 on your own, and then bring your paper to me to get your stamp before you move on to number 10. So now you can pause the video and take care of number 9. Number 10. The graph shown below represents the relationship between the number of donuts, here's our number of donuts, that's our x, and the cost of the donuts that a bakery sells. So here's our cost, that's our y. What is the unit rate and what does it represent? So they're asking us two different questions. What is the unit rate? That means for one donut. So I'm going to write blank for one donut. And then what does it represent? Oh, actually that answers that question. The cost per donut. It's not the number of donuts. Okay, so the unit rate means per one or for one donut. It wouldn't make sense to say how many donuts for one cost, but it does make sense to say how much for one donut. That's what you would be asking when you go into the store. So let's think about it logically. How much for one donut? So that means that I can get rid of B and I can get rid of D because I need it to be the cost per donut. Cost for one. So now I have it narrowed down to two answer choices. And is the cost $2 per donut, or is the cost $4 per donut? Well, let's look at our graph a little bit more closely. I'm going to look at my x-axis and I see that I'm numbering by twos. So for two donuts, it looks like the cost is $4. But that's for two. That's not what I want to know. I want to know how much for one. Well, 1 would be right here. And if I go up to 1, that's going to cost $2. So 2 is the cost per donut. Now I need to be careful because if I had just looked at my first number here, I would have thought it's $4. So make sure that you're reading the how your x-axis is spaced on questions like this. We always want to know exactly what the numbers are, not just kind of what it looks like. We always figure it out exactly. So one donut, $2. Two donuts would be 4, but we don't care about that. We don't want 4. So now you have one to do on your own. So now you're going to pause the video and complete shaded number 10 on your own. And then before you move on to number 11, I'd like for you to bring your paper to me for your stamp. Number 11. A scatter plot of a data set is shown below, actually over to the right. Which statement best describes the correlation of this data set? Okay, does it have positive correlation, negative correlation, no correlation, or compound correlation? First of all, as far as I know, there is no such thing as compound correlation. They're just going to give you answer choices that are made up. Now, no correlation, remember, no correlation is where we have dots all over the place, and it's just like a mess. That's where it's completely random. So it's not no correlation. So now we're down to positive and negative. So positive goes up as you go to the right. Negative goes down as you go to the right. And this one goes up as we go to the right. Okay? So as we move further up, we get higher instead of getting lower. So this would be positive correlation. Now please pause the video and complete shaded number 11 on your own. And then before you move on to number 12, please bring me your paper for your stamp. Number 12, what does a scatter plot with a linear relationship look like? Well, linear has the root word line. Okay, so in general, it's a scatter plot, so it's not going to be exactly a straight line like when we're plotting points on a table. But it is going to generally make the shape of a line. So there are several. This is a positive correlation, so it is linear. And so that would be something like this. Okay, so in general, we're getting this basic line that direction. And it's going up, it's positive. Okay, then we have negative. Negative correlation is also linear. So there's several types of linear relationships, and that would be the opposite, where we start up high and we go down. So maybe like this. Okay. So in general, we're getting this kind of trend line. And then I have this other graph over here because I wanted to have plenty of space for you, but also keep in mind that sometimes linear relationships may go like this. So they may go straight across, or they may go straight up and down. Okay, so that's still a linear relationship because it still makes generally a line, either like this or like this. These two are the ones that you're most likely going to see. Now number 12 on your own says to circle, let's zoom out just a little bit. Circle each graph that represents a linear relationship. So there's going to be more than one here that you're going to circle. So anything that represents a linear relationship, I'd like for you to circle. When you're finished with number 12, you can bring your paper to me for a stamp. I'll be checking and making sure that you have all of the linear relationships circled and that we didn't accidentally get some extras. And then you will be finished with your review. So at that point, I need you to look back over your work, see what's kind of still a little bit confusing to you, since you may still have some time, and talk to me about those things so that I can maybe give you a couple of other example problems or maybe talk through it a little bit more with you one-on-one. So please go ahead and pause or stop the video now.